Let's go to question number 146, LRU cache. This is medium question. Let's get into it. Design and implement a data structure for least recently used LRU cache. It should support the following operations: get and put. Get key. Get the value will always be positive of the key if the key exists in the cache. Otherwise, return -1. Put key value. Set or insert the value if the key is not already present. When the cache reaches its capacity, it should invalidate the least recently used item before inserting a new item. The cache is initialized with a positive capacity. Follow up. Could you do both operation in one-time complexity? This means is when get and put operation is occur, we cannot use any iteration or any binary search to do it. So how we can do? Okay, let's brainstorming. If we implement LRU cache, we needed to store sequence and also we sequence and the item in data structure, data in cache or not. Sequence is we needed to use list or only list, and then cache or not. If we check this one with constant value, yes, we can use map. How about sequence? If we sequence, then if we use the list, but sequence, the problem is inserting value and popping. It always able to pop, and if we implement the constant time, list is cannot, because the last item is okay, but if we insert the first item, it cannot, because if we implement this one, we need to pop this one and the popping and then inserting again. That is the reason why list insert and delete operation is linear time. Then how we can do it? That's right, we can use DLL. DLL is doubly linked list. Doubly linked list is like this. 1, 2, 3. So each node has two pointer, previous and next. So if we delete this one, it's very simple. Just disconnect the relationship, and this one cannot go to here. Does it make sense? The middle also same. Just disconnect to this one and this one, and then connect new relationship is this. So in this case, 1's next is 3 previous is 1. So that means it's the same as this one is disappear, because this node and then this node and then all of another node cannot able to access this node. So this one is the same as this one is deleted. Does it make sense? So now we will use DLL with map. Okay. If we implement DLL, we need to make node class, and then and initialize this object. We need value and pref, previous, and then next. and then I will store value is value, self ref is ref, and self next is next. And then when it initializes, I will store capacity, able to access get and put function, and then we need the map. And then I will make two things. First is head and another is tail. Self head is node. Then I will make initial value. Details. And then self tail is node tail. And then self head next is the self tail. I will pointer each other. Self tail ref is self head. So now head tail. And then when your item is inserted, I will do like that. So head next mean is the first item of linked list, and then tail previous is also the final item. Did it make sense? So I will not save any data in head and tail. That object is just pointing first data and the last data. Okay, next I will implement the get. I will make alias, improve the readability, and then map is self map, and head is self head, and tail is self tail. Okay, now if a key not in map, how we can do? We return -1, -1, and then now we create a node, new node, and then no, it just get. So find the node via key, and then move it to front, because this is the LRU cache. Okay, how we can find the node via key? Yes, we able to use the map. So key is, that is the node what we looking for. Node is map key, and then I will move it to the front. So maybe this node is front has the node ref, and then next is node next. So in this case, we are able to access the previous node and the next node. And then now we need to pop this one and then move it to the front. How we can pop? That's right. If we can pop, we need to change to pointer, node previous and node next. My approach is I will do node, and then now here, now is this, right? So first I will do node fret to prep next point to node next, and then node next prep pointing to node prep, and then that means does not connect pointing here. So node prep next is the direct node next. Does it make sense? Okay, first node prep is next. Okay, now is this. So node prep next is this one, right? Is node next, pointing node next, this one. So I will delete it and then update to here. Then now I will do node next, this one. What is this? Node next is flag, right? Node flag. So node next is flag pointing to node flag, like this. So this is detached. So now we will link this one to head. So now situation of head may be head and head next. So first we will pointing node to head, node previous to head, and then node next is head next. So node prep pointing head, and then node next pointing head next. Then now I will change which one first? This one first? No. If we change it head next is node, there are no way to access here. I will show you. If I change head next to node next, how can find head next? Because this one does not head next, just node. So this one is the lost child. So if we prevent this edge case, we needed to change this one first. So head next previous is node. Head next prep is node, and then now head next is node. So in this operation, this one will be this one, and this one disconnected, and then next head next, this one is disconnected, and then pointing to node. Then return node value. Does it make sense? Alright, okay, last. When you put the new item, there are two conditions. First is the key already stored in the linked list. At that time, we just update it because key must be unique. But if there are no key in a map, we just create a new one. So first we need to check the key already in the map or not. If key in map, I will copy and use. If key in map, how can check it? Just key in map? No, we will use this one. If we use this one, because we have the extra benefit. Okay, I will show you why it is. Self get key. If it exists means if this is not exist, return -1. So exist means not -1. I just at the time we just updated the node has key value. So this time we just do head next val is value, and then return. How is it possible? Because self get key, if this exists, this operation will be run. Find the node via key and node it front. So you just find the key always store the head next. That is the reason. Head next is the one we are looking for. And then next I will do, first we need to check the capacity. So if length map is capacity, we need to delete map the key. How we can find the key? But the key is not same as this key, right? This one is key of last item. So we can find last item is tail the previous, but unfortunately this node does not have any key. How we can do it? That's right. Just make a new one. Self key is key, and then we receive key. Initialize with 1, and then next time when they create the node, we just input key also. Then now we can get key like this. Previous key. Did it make sense? And then next we will delete the last one. So actually maybe last one is maybe like this. This is tail, and then this one must be tail previous. We can access with tail previous like this, right? And then there are one more. We need the tail previous. In this case, we needed to change this one, delete, right? And then connect this one. Now we will do, so if we do first, we will do tail previous is the previous, next is the tail. So tail okay. Next is tail, and then tail next is tail previous. Did it make sense? And then this one also we can implement like this. Tail previous is tail previous, and then tail previous next is tail. Is it the same? That's right. First with tail previous, the next, this one, disconnect this one, and then attach here, and then next, tail next. Oh, no, tail, no. And then tail previous is tail previous, this one, to disconnect, and then tail previous. Now this one is connected, and then this one also same. Tails previous to tail previous. So this one connect, and then add here, and then tail previous next. Tail. Now this one is changed to tail previous, right? because we already tails previously. So this one next, this one, and disconnect and then connected. So anything is okay. We will use the second one. Okay, now create a new node and put into front. Create a new node is node and key is key and then value is value, right? And then node, I will copy and paste this one. Finally, the add map key is node. Okay, I think I'm done. Let's check the code. Okay, looks good. Submit. Awesome. Okay, in this time complexity is constant because get operation there are no iteration, right? And then put operation also there are no iteration. And then space complexity is linear because we use map and double linked list. Thank you.